Good morning, Jura committee members. It's an honor to present my research journey and doctoral thesis proposal today. My work reached advanced material computational modeling and sustainable engineering with a focus on the next level biome composite. Let me guide you through my academic foundation, research experience, and the innovative scope of my thesis. My presentation is structured into four parts. The first one is my CV and academic background. The second one is my research experience. The first one is thesis project, and the last one is conclusion. First of all, my name is Bùi Đào Quang Thành. I aspire to become a leading researcher at the intersection of advanced materials, structural engineering, and energy efficiency technologies. My expertise in computational simulation and programming, combined with my dedication to sustainable innovation, compel me to pursue transformative international research opportunities that will elevate my both scientific impact and personal growth. About my academic background, I graduated from Lương Thế Vinh High School for Gifted in Đồng Nai Province, Vietnam. I specialized in mathematics. This early focus on quantitative discipline laid the foundation for my analytical skill. And after that, I pursued the program de formation d'ingénieur d'excellence au Vietnam, BFBV, at Ho Chi Minh University of Technology in Ho Chi Minh City, Vietnam. That is a program between collab between Vietnam and France, with some famous universities like INSA Lyon and EMBC. My major is civil engineering, industrial and energy efficiency. Currently, I'm working as a tech institute Hữu Tech University in Ho Chi Minh City, Vietnam. My main major is simulation and AI. In Lương Thế Vinh High School for Gifted, at 10th grade, I'm the top 4 exam for excellent student. In 11th grade, I'm ranked 1 in class. In 12th grade, I was being directly recruited into IT department at Ho Chi Minh University of Technology. And there, every year I always have the certain awards or publication to ensure my continuity in research as well as fuel my passion for research. And well, when I graduated, my degree were recognized by CTI as an European master degree. And let's move to my research experience. In 2020, I joined the BBV Student Scientific Conference with two projects. The first one is thermal analysis of the material selection for optimized heat transfer mitigation. In this project, I used to use a special machine to estimate isolate the parameter of the material. After that, we use that data to optimize the thickness of the wall and choose the material to minimize the heat transfer through the wall. With this project, I got the top one conference. Then the second one is optimization analysis of bidirectional bending in column design. In this project, I used the previous case study column to build a diagram, and after that, I use that diagram to optimize the future design of the column. And this is one of the most important project in my life. In this project, I collab with the Vietnamese government to study the spread of COVID-19. In this project, I use the CFD Autodesk to simulate the spread of COVID-19 into specialized environment in Ho Chi Minh City. The first one is a room, and the second one is the small street. This project helped the people while they come back to Ho Chi Minh City to work and study after the COVID-19 disease. And this is my first international paper, with the title is Improved Detection Network Model based on the YOLO V5 for warning safety in construction site. In this project, I used to build and train a AI model to warning the people in construction site wearing the PPE to help them to avoid the accident in dangerous site. After that, I improved the model to maximize the accuracy and minimize the response times. And as I mentioned, I'm currently working in Surtech. My into two main major. The first is simulation. I simulate the dynamic problem like this, and the result of this simulation is the energy, absorption energy, kinetic energy, or total energy. I use that energy to build better structure to face with the dynamic problems. But there is a problem in Vietnam. Uh, it's hard to get the permission of do experiment with the ultra high speed in Vietnam. So I think that conducting a part of my thesis work in laboratory in France would provide valuable opportunities to advance in the field. And the second main major is AI. In this major, I learned about some latest technologies like CAN, Kolmogorov-Anov network. With this technology, we can build the function from the big data. With this function, we can easy to find out the future result of the phenomena. And the second one is physics informed. With the physics informed, we can build an explainable model to predict the future phenomena. To prove that I'm working hard in this major, I was invited to work in ITP program in 2025 in University of Gent in Belgium. In this program, I will learn about how to collect the AI and the energy efficiency. So we move to the thesis project. My thesis is PhD consultant thesis, with the title is multi-scale modeling of the physical behavior of bio-based artificial fiber reinforced with the nanoparticles using a machine learning interactive potential. In this project, collab between the Université Paris-Saclay and USDX, University of Science and Technology of Hanoi, and Université Paris Saint-Vardemont, and yeah, about the context of this project, the global aerospace industry consumes about 770 kilotons of research every year. Figure expect to double within the next 20 years due to the increased demand for human mobility. Traditional materials used in aircraft like aluminum, titanium, carbon facing growing concern over research critically due to their limit availability. So the question is how to reduce it. I suggest that we should use the natural fibers and natural materials like cellulose. Of course, when we use this material, we have to have an overview of the mechanical behavior of this material. So to achieve this objective, a multi-scale approach will be implemented at three levels. The first one is nanoscope. The core of the project will be based on molecular dynamic simulation using advanced potential based on machine learning, with or without ultrasound. This simulation carried out by ICP will provide essential information for the higher level micro or meso. As part of numerical homogenization process developed by the UPEC, and that micro and meso level specific multi-scale tests will be carried out by the partners like USDH, LMPS, and Onera to characterize the physics and mechanical properties of the fiber. The test will be designed and validated and progressively improved using the finite element simulation at LMPS and the result of DM simulation. The experimental data obtained will be used to refine and validate the numerical models, thus ensuring their reliability and applicability in the future experiments. Finally, all some uncertainty relates to the components of the artificial fiber will be taken into account using stochastic approach developed by UPEC. After that, um, I can reinforce with the natural or naturally derived fiber to ensure the sustainable mechanical behavior like this. And our future goal is applicability and methods of valid experimental results. With the obtained experimental data, we can train the AI model to save the time for prediction future phenomena, and we can use this data to validate the numerical models, and we can compare the model AI model and numerical model to which is better. Yes, that's all. Thanks for your attention.